recording. Okay, so now we can start. So hi everyone. I hope you have a lot of questions now for today. Who is going to ask the first question? You?
Yeah, sure. So,
okay, so what's your name again?
My name's Alex.
Alex is asking the first question, so I'll read the question for you for the home audience. Yeah.
Okay, so like for the partial chain rule, why is it the sum of like the two different partial derivatives, like del f over del x over del t plus? Like why is it plus?
Oh, so this is not about the this is not part of the midterm, right?
Oh yeah, I guess it would be part of it.
Yeah, that's
okay.
not.
Oh yeah.
So can we maybe postpone that to after midterm stuff? Yeah, but I mean that's a very good question, obviously. So there was a question about partial derivatives, which is not in the midterm, so we can just postpone that too. Yeah, but that's an excellent question. I'll tell you.
Okay.
So yes, question.
I just have questions from the textbook, but if someone else has them,
Okay, so do you want to go on? And,
are there no other questions?
oh, okay, so I have. Yeah, there's a question?
Oh, I have a question.
Okay, yeah, go ahead.
So are there gonna be proof type questions on the midterm?
Yeah, I was asked this many times, and I actually mentioned in class. So there's a question about if there is going to be proofs of a statement. No, proofs are not part of the exam. So,
Okay.
you know, we had some difficult proofs even. So some of them were easier, but proofs are not part of the exam anyhow. Yeah.
Okay. How about like sketching type questions? How like what degree, like how well do we have to know how to sketch?
Sketching is is fair game, and because you will do your problems on a piece of paper and then take a picture and load the grade scope. So like the way you did your assignment, exactly like the way you did your assignment one. So sketching is it's just fine. But the thing is, you're not allowed to use any sort of programs or calculators or whatever to do the sketching. The sketching should be done just by you and your brain. That's all.
Okay. All right. Sounds good. Thank you.
Okay. Excellent. So there is a question in the chat. Maybe I hope it's private. For some questions, when we find distance, we use projection, and other times we use cross products. Over how do we know which to use? For distance, we use project. Yeah, usually projection cross product was when we wanted to find a vector, the normal vector, and then we use that normal vector to find the distance. So that was when the normal vector is not given, we use the cross product. When you don't, when you don't have the normal vector, you use cross product, or the vector is obtained by cross product, and then you use the projection method to find the distance. So yes, indeed, that's a good question. Did you get your answer? Yeah, there's an answer. So there is another one. Are we allowed to write on a tablet instead of on paper for the? No. The tablet is not okay. Please don't do that. Yeah. Just write on a piece of paper. I mean, okay, let me think about it before completely. I have to consult with some of my colleagues, see if there's an issue with using the tablet or not, because tablet is considered a kind of electronic device, and I'm telling you, don't use any electronic devices. So I would say no, don't use tablets. Please write it on the book. Okay, so this was the tablet question was answered. So there's another question is, can you do a quick review of Kepler's second law? The textbook does not go into details. Well, I can do that if we have time at the end of this lecture today. I mean, the Kepler second law basically was this area law that we discussed. And the idea was simple. We just wrote down Newton's equation using angular momentum. You remember? Kepler's second law. This was the area law. So this is sun in one of the foci of the ellipse, and this is Earth. So we said that the area that's swept by Earth in traversing its orbit around the sun is the variation of area dt is constant. So to derive this law, what we used two things. First of all, Newton's law. So proof, if you want, it was F equal to ma. That was by Newton's law. And then we had the notion of angular momentum. Remember angular momentum? So angular momentum was L equal to, remember what was the angular momentum? R cross mv. So R cross mv. So v is the velocity vector, right? And R is the radius vector. So this is R. This is v. So this is basically your momentum vector, and this is this. Anyhow, so we had so L is equal to m R cross, and so B is equal to R dot, which is the R dt, right? If you want. Okay, so this was R dot R dot. And then we used another fact about this, about the motion. What was the other fact about the motion? That this force is always along R. That's central force, I think. So also, central force. So what is central force? Central force says that this F is along R all the time. Force that's attracting is the sun attracts E along the force that's always along this line R. We don't know how much of R. It could be a multiple of R. Twice R minus whatever, but it's always along R. Then what we did, we took derivative of this here, then we said dl dt is equal to dr dt plus, so let's use this, for example. So this was dr dt m times, then this is, of course, R dot, which is dr dt again, plus m r cross dr double dot dt, right? But this is exactly acceleration. And Newton's law says that acceleration is along the force, but the force is central. So this term also disappears. This is also disappear. So this is constant, and this is, we argued that this is exactly the left-hand side. So that's a bit more than what you need to know, but okay. Okay, good. So there is a question. Can you do a question on finding skew lines? Yes, I can do this question. Let me do a question on finding skew lines. We did something about skew lines. So a question, for example, show that the lines. So give me an equation of a line. You know in how many different forms you can give equation of a line. You can give parametric form, right? And you can also give the equation in symmetric form, right? So let's give me in parametric form. Say for or symmetric form. So x minus 1 over 2 equal to y over 3 equal to z plus 1 over 2, and x over 3 equal to y minus 1 over 4 equal to z over 5, or over 3, for example. Show that these lines are skewed. So two lines are given like that, and we are asked to show that these lines are skewed. How would you approach this? Well, the first step is, so being skew, first of all, what skew means? Skew means the following thing, right? It means that they don't intersect each other, but they are also not parallel to each other. So skew means they are not parallel, well, that's one thing, and do not intersect. So if you are asked a question about showing that two lines are skewed, you have to do both. You have to show that they don't intersect and they are not parallel. Okay? So first of all, let's do the first one. Why they are not parallel? Well, okay, why? Why these two lines are not parallel? Well, what is the direction of the first line? Is 2, 3, 2. What's the direction of the second line? Is 3, 4, 3, right? Is 3, 4, 3. Now the question is, are these two lines parallel to each other? Are they parallel? That's the question. For them to be, are they or not? No, exactly no, because they are not equal or scalar multiples. Exactly. Absolutely correct. They are not parallel because you cannot write this as a multiple, scalar multiple of this one with some number. They are not a scalar multiple of each other. Right? So if you say they are not a scalar multiple of each other, you have already covered the case that you're also saying that they are not the same, because being the same means that this one is a multiple of the equal to 1 times the other one. But you're just saying that no, it's not even another multiple of this, not just one. So anyhow, so these guys are not parallel. That's fine. Now the question of intersection. So intersection is a bit more interesting, right, as you remember. So we have to solve that there is not even a single point that would satisfy this equation and this equation. So let us write these equations in parametric form. So for this question then, write in parametric form. So your parametric form tells you that x is equal to 1 plus 2t, y is equal to 3t, and z is equal to negative 1 plus 2t. Right? Because we put this equal to t, right? And we solved it. Just put it equal to t and we solve it. Okay? And we also put it equal to t to obtain the parametric form and solve it, right? So the second line is x is equal to 3t, y is equal to 40 plus 1, z is equal to, this is also t, equal to 3t, right? Now, we want to show that there is no x, y, z that satisfies this and this equation. Now, here is a very important point. What is that important point you remember?
That the parameters can't be the same.
Exactly. The parameters, we are not allowed to assume that the parameters are the same. So we have to choose a different parameter here. So this is 3s, 4s, and 3s again. And the reason for this is that, yeah, I mean, these lines may reach same point, but at different times. Nobody said that the time on this line that reaches this point should be the same as the time that this line is reaching that point. After all, we are not interested in time, we are interested in points in space, right? So that's why we have to choose S. Now we have to show that these things don't have a common solution. So now then you remember the method was how? What we did. The method was we took the first two. So this equal to that, this equal to that. So take the first two. So we get 1 plus 2t is equal to 3s, and 3t is equal to 4s plus 1. Let's solve this equation. This equation is 2t minus 3s is equal to negative 1, and 3t minus 4s is equal to 1. Okay, multiply this by 3, multiply this by 2, and add. If you multiply this by 3, multiply this by 2. Okay, so by minus 2, I mean, and then add. You cancel t this way, then you get negative 9s. Here is plus 8s. Is equal to negative 3, negative 2. So you obtain indeed, so I have negative 9s, so you get negative s is equal to negative 5, sorry, s. So you get s is equal to actually 5. Okay, so we found the value of s equal to 5, and then we can just sub it into any of these things. So let's sub into this one. First one, sub into your first equation again, you get 1 plus 2t. Well, this is 5, so this is 15. So here you get t equal to 7. Right? Because 7, 14 plus 1 is 15. Okay, so the only solution for the first two equations is, common solution is t equal to 7 and s is equal to 5. Now, then what would be your next step? We are not done yet, yes.
Set those values into the equation.
And if they match, but let's see what we get. We get from here, you get indeed Z is equal to 3S 45. That's one value of Z. But if you sub into here, you're going to get, so I just write it kind of. So we get Z is equal to -1 plus 2T. T is 17, so it's 14, it's get 13. And they don't match. You have to write it. I mean, okay, because they don't match. So what does it mean? This sort of calculation shows that actually there is no point XYZ which is common between the two lines, and as a result, these two lines are askew. And we also check that they are not parallel. So these two lines are askew. This was a very good question. Thank you for asking. Yes.
Could you find a distance between the two?
The distance between the two, yes, we can. Yes, we will. Yes, yes.
Is this the kind of question that you could ask on something, or is that too
Why not?
straightforward? Like that's is that like a type? I'm just confused as to what type of questions are going to be asked since there's no aspect.
Right. So I have there is a question, which is a fair question. What kind of questions are going to be in the midterm? So the questions are going to be very similar to what we had in assignment 1, for example. Some of the questions, just a few, I would say, could be just a bit more complicated than just these assignment question, but more basically it's same level and same level as those suggested problems that you have in the book. So if you study type of questions that are in assignment and also suggested problems, then we have then you're in good shape. And this is typically one of these sorts of questions. Yes.
I was curious about, you didn't go into too much detail about but it wasn't the textbook. Like, is that are those types of questions?
Yeah, so there's a question about torque and what was it? Well, we did angular momentum, which is similar to torque. In the book, there is not much emphasis on those. I mean, but I just gave the definition, and we did one example or two. That's all, and that's at the level that you're supposed to know. I mean, not more than that. Yeah. So I mean, because after all, this is not a physics course. I mean, so yeah, very good.
Could you go over distance? Could you go over the distance between two skew lines?
Yes. So the question is doing the distance between two skew lines. How would you do the distance between the skew lines now? So we have these two lines or skew lines. So can you do the distance? So we want to find this distance d. Between skew lines. Do you remember the method? Anyone remembers the method? What was the first step we did? Someone asked the question, so maybe you have already thought about the question.
Well, is it you cross the two direction vectors?
Right. So the first step exactly is to find the direction of this, right? So we want to find the this direction first of all, right? So we need to find this direction. Okay. So this direction is, say, maybe n. this vector n, is equal to the cross product of the directions for this line and that line, right? So it's equal to, say, ABC cross, so I just call this ABC, cross A prime, B prime, C prime for the second line. In this case, it's easy, so this is 2, 3, 2 cross, so 2, 3, 3, oh, okay, so I erase this, 3, 4, 3. So let's do the cross. I, J, K, right? And then 2, 3, 2. And then 3, 4, 2. So that's equal to, well, this is I times 6 minus 8 is negative 2.
The last line should be 3, 4, 3. The last line should be 3, 4, 3.
Oh, 3, 4.
And the determinant, the last row.
Oh, 3, right. Very good, thank you. Okay, so this is like 9 minus 8 is 1, negative j times 6 minus 6 is 0, plus k times 8 minus 9, which is minus 1. Okay, so we are going to get this vector n is equal to, so I may not write, I don't want to write, because it's not the standard in this course, so I just write. Anyway, n is equal to 1. And so this is 0, and this is negative 1. 0, negative 1. So this is like I, negative k. That's your vector n. Okay, so we are good with the first step. And then what was your second step? What did we do after that? What did we do? Yeah? Anyone remembers?
You solve it as a point to a plane.
Sorry?
You solve it as like the distance from a point to a plane.
There is a formula. Yeah, that's one way to do it. There's a formula for a. Okay, there are several solutions. Okay, there is also a projection formula, but then we also did as a so distance to a plane. So let's go by the second route. So there is also, so after these two methods, are available. One is I just take a distance, I just pick a point here and then find the distance to the plane that is passing through this. So this is line L1, L2, that passing through L2 and is orthogonal to this L, to this M vector, right? So that's what we do. So use distance to a plane formula. So that's one method we'll do. But the way I did it in class, I remember I did it in a different way. I did it using projection formula, right? To use projection formula. I remember I did it using this method. Okay, so let's do by method one, because this gives me an excuse to discuss some issues. Yeah, there is an answer about proj n. Yeah, I think that's correct. I did it by that method in class. Now, you remember the formula. Actually, this is independently important. The formula for the distance between a point and a plane, right? That's that formula. I said you have to memorize it. So let me write it here. So this is 3, 4, 3. Formula for distance between point P with coordinates x0, y0, z0, right, and the plane ax plus by plus cz plus d equal to 0. What was the formula in this case? Do you remember? So this is the picture that I'm now looking at in my mind. This is the point P equal to x0, y0, z0, and this is the distance d. And this is the plane ax plus by plus cz plus d equal to 0. Okay. What was the formula for the distance between a point and a plane? Yes.
Is it the magnitude in the numerator, the magnitude of ax naught plus by naught, that's not k? Or
D.
d, sorry, over the square root of a squared.
Exactly. So the formula, remember, was this. D is equal to absolute value of ax0, by0, cz0, right? by0 plus cz0 plus d over square root of a2 plus b2 plus c2. Okay, so now you are done, provided, so by this method, which is really straightforward. It's a bit longish, but it's straightforward. So you are done, provided you find now the equation of this plane that contains this line L2, and just pick any point on this line and find the distance. I mean, it doesn't matter where you find the distance, right? They're all the same. How do you find the equation of this plane L2 that contains the line L2 and is orthogonal to this vector n? Yes.
It has the normal vector n, and it just chooses orthogonal.
Exactly. So after this now, it's very easy. You just, okay, so there was an answer. Yeah. So just pick a point on L2, and that's it. And you have this normal vector, and the equation of the plane is a times x minus x0 plus b times y minus y0 plus c times z minus z0 equal to 0. Remember, x0, y0, z0 is not this thing that I'm doing here. It's a new point for this line L2. Okay, so you find the equation for L2, the plane that contains that, and then just pick any point on L1 and find the distance using this formula. So that's straightforward. So I'm not going to finish it because now the idea is clear, because it takes time. So it's better to go to other questions now. The projection method would work also, and that's the way I remember. Barely remember I did it that way in class. But which way you want is fine. Okay, so maybe we have to move a little bit forward because we are kind of imbalanced now. We are too much emphasizing on first sections, first few sections. So what about like continuity and derivative and stuff? It's very important, I tell you, okay, so there was a question, by the way, about with regard to curvature, we obviously need to know the curvature formulas and how to apply them. But do we need to know the derivations of each one? No, you don't need to know the derivations of those formulas. I mentioned that in class, actually, right? So do you remember how many different formulas for curvature we had? No, like, I mean, it depends how you count, but basically, I think we had at least 3 formulas, right? One formula for curvature was, yeah, 3 is correct. One formula was, the original formula was kappa is equal to what? du ds absolute value. What is u? It's dt ds. That was the first formula, right? We looked, what, do you remember what t was? What's that?
R plane.
So,
R plane. Or
no. T is a vector. T is a vector. T was unit tangent vector. So let me put it this way, because this formula is important. Of course, I said it's conceptual. I mean, it's not for calculations. Yeah, so this formula, yeah, I had several questions privately asked. Actually, T is unit tangent vector. So this T is, yeah, I mean, like R prime T over absolute value of R prime T. Remember, this was T. And then we parameterize it with respect to arc length. So that was already quite an important issue. Parameterizing with respect to arc length. You have to be able to parameterize. So changing the parameter from T to S, that's important. And once you do that, you get this one. But then there was another formula, kappa was equal to. So the main formula, your main weapon here would be, what is the formula in this case? A magnitude of R prime T, right? Cross R double prime T over absolute value of R prime T to power what? 3. So this was the most useful formula. And for plane curves, we had the formula for graphs. If you have a graph, a curve which is a graph, its curvature would be computed using this formula by parameterizing the graph in that form. What was the formula that we got? For curvature. Curvature is equal to absolute value of f double prime of x, right? It's just like here, but a little bit easier than that, over 1 plus f prime squared of x to the power 3 over 2. Remember? Okay. So about the curvature, yeah, it's important, you know, we had problems where we were supposed to find a point where the curvature is maximized, minimized, or just computing, things like that. So this was important. Okay, all right. With regard to, okay, so I answer, are you able to review section 73 in chapter 3.2? What is that? Show that if the speed of a particle traveling along a curve represented by a vector valued function is constant, then the velocity of function is always perpendicular to acceleration function. Yeah, sure. That's a very good question. I mean, so is this number 73 in chapter 3.2? Right. So the question is that I know that this r prime of t is equal to constant. So it means that the velocity vector, so it means that the speed of this particle doesn't change. That's what it means. The velocity changes, but the speed doesn't change because the speed is this magnitude. Speed is a number. It's constant in t. And we are asked to show that, the acceleration vector is perpendicular to the velocity vector. Show r prime, which is acceleration vector, is orthogonal to r prime. This is acceleration. And this is velocity vector. So we are supposed to show this. This is indeed a very important question, because no matter what, you will face this sort of issues in other courses and later on in math also. So let me tell you how this can be done. Well, what does this mean? If this is equal to constant, you can square it. You get this squared is equal. Well, if you have a constant, if you square it, it's also a constant. It doesn't matter. It's still a constant. So this is also a constant. But what is speed squared? Speed squared is velocity vector dot velocity vector, right? Because that, by definition, is r prime of t dot r prime of t. So we are saying this is constant. So this is the same thing as this. Square, magnitude square of a vector being equal to dot product of vector with itself. Now that we have found that this is a constant, we can just differentiate this. So differentiate on both sides. So now, if you differentiate on both sides, here you get, well, r double prime of t dot r prime of t plus r prime of t dot r double prime of t equal to 0. And what rule did I use here in order to go from here to there? Product rule, exactly. It's a product rule, but for dot products. But it's really product rule. It really boils down to product rule. So I just don't write it. It's product. Okay, but now, but dot product is symmetric, so this is equal to twice r prime t dot r double prime of t equal to 0. So r prime t dot r double prime t is equal to 0. So it means that velocity is orthogonal to acceleration. Oh, this is velocity, this is acceleration. And that's what we wanted to show. Okay. Good. Next question. Now I tell you, it's important to be able to show that like some limits do not exist. And usually the methods that we use, we approach the point through different lines, and we make sure that if they take different values, the limit does not exist. But also you have to be able to show that some limits exist. That's also important. That could be sometimes a bit challenging, so you have to use different methods that discussed in questions and in your assignment to show that actually, yeah, the limit does not exist. Or does exist in that case, sorry. Any questions? Or? Okay. Will you let us draw the level curves like the section 4.1? What do you mean, will you let us draw the level curves like this? You mean, I'm not sure exactly I understand your question, sorry. So the question is, I saw some answer for the exercise on the book. Yeah. Oh, you mean, yeah, so the question is level curves is like 3D? No. In 3D we have level surfaces. In 3D we have level surfaces. Right. So that's the difference. I mean, yeah. So there are two issues: level curve versus level surfaces. Oh, okay. So that's a fair question. Okay. So level curves and level surfaces. For this, we have an equation like f of x y equal to 0, right? So that's in 2D problem. But this one is f of x, y, z equal to 0. That's in 3D. Right? So this typically, you get a surface, you get a two-dimensional, typically, generically, I would say, you get a two-dimensional object. But here you get a curve. Curve. Surface. That's the difference between the two. So that's the kind of picture. And indeed, about this sort of drawings, it's important also to identify surfaces. So, you know, quadric surfaces. Know your quadric surfaces. Those surfaces, those naming give me trouble also. So you should remember those names. Quadric. That's it. And you should be able also to draw quadric surfaces. I give you, for example, a question of a quadric surface, I ask you to draw it. I mean, that's fair game. And also naming it, maybe some picture is shown, like in assignment 2, you will have those pictures. And then you ask, you haven't looked at your assignment 2. It might be a good idea to look at some questions in assignment 2, because some of the questions are kind of relevant to this exam. So, okay, so, and of course you have Aftab at 2:30, so he has a tutorial today. And okay, so there is another question: should us point out some important points of a surface when we draw it? Yeah, I mean, some points might be important indeed. For example, if you're drawing a cone, you should give the idea of cone. I mean, there is a singular point, tip of the cone, that's important. And also it's important to know that cone is not like usual ice cream cone. It goes the other side also. So there's an ice cream cone, and also there's an inverted ice cream cone. So stick together, right? So they kind of tuck together. So you have to kind of draw that. And for other surfaces, yes, for example, if there is an ellipsoid, you know, some ellipsoids have this feature that ABC are not the same. It's elongated along one direction, less elongated along the other direction. You have to show that in your, don't draw a sphere for ellipsoid. That's obvious, right? So, okay, so
can we use a formula sheet? Can we use a formula sheet for the? Can we use a formula sheet for the midterm?
Not at all. No.
Not at all. Sure.
I thought I was very clear in my messages, wasn't I? Formula sheet, cheat sheet. I mean, not at all. I'm gonna emphasize it again. I'll send another message since you asked. Okay, thank you for asking. Yeah. No, no. It's all what you learned and what you're able to, you know, you're able to digest and memorize. Too many formulas is very complicated. That's true. That's true. Too many formulas. Yeah, that's true. That's a fair comment. Yeah, I agree. But it's kind of good to be able to do this sort of things at one stage in your life, right? So that's good.
So you mentioned there was two formulas for finding like a distance from a point to a plane. Like there's the projection one, and there's also like a cross product one.
Yes.
Should we be able to use both, or can we just like do one?
Well, you wouldn't have time to use both. I mean,
Okay.
just use one method. I actually like the way I did it here. It's a bit longish, but it's better. I can drive the other one, but it's kind of, yeah, use any method you want, but don't do both because that's totally uncalled for and unnecessary. Right?
Yep. Thanks.
Thank you. Is the midterm designed to take the whole 3 hours, or is there time for uploading? Oh no, I mean, there is a 15 minutes time at the end, as I said, for uploading your writings into your camera and then uploading into the system. So it's going to be similar to grade scope, assignment 1, similar process. Yeah, I will give you 15 minutes extra to upload the stuff. Yeah. Yes.
With that, one of my roommates were in a Zoom exam the other day, and they found that like being on Zoom was also trying to upload PDFs onto the computer, like it wasn't working a lot of the time. So is there allowance for like some buffer time if the TA
Yeah, that's a good question. Sometimes it said, indeed, that's a good point. Indeed, it said that sometimes if you're on Zoom, you cannot upload. So what I will do, there is Dropbox in OWL. You can also upload on Dropbox. Maybe I will just say, well, upload your questions on Dropbox, and then, but one way or the other, I have to decide. So I will let you know tonight, yeah. Because there's so many unknown factors about this. I mean, it's kind of, yeah. Yeah, you have 3 hours and 15 minutes for me. Okay. If you want to put it like that, yeah, sure. Yeah, 3 hours, 15 minutes. Okay, guys, I'm
For
going to turn off. Sorry?
sorry.
Go ahead. No,
I
go
just
ahead.
have a really quick question. For the exam, it's uploaded as a PDF to OWL, right?
Yeah, you're uploading as PDF file, exactly.
But are we able to print out the exam during the 3 hours?
Well, I will send you the PDF file. I upload the PDF file either through Gradescope or through your on your resource. So if you log into OWL, you will have access to your question. I mean, you don't have to print it even. There's no point of
Okay.
reading it. You can just read it on your computer screen. That's the only thing that you can do.
Okay, got it.
Yeah, I mean, there are too many unknown factors in this game, so I don't know. Should be okay. Okay, so I'm going to turn off the cam and then we go. I'm still here.
Thank you.
Thank you, guys. Thank you. And let me know if you have any questions and we can just